Hi, my name is Mariko. You might know me from this form, my Twitter. I'm pretty much everywhere online on that handle. I am a JavaScript engineer at a company called Scripto. We make collaborative writing software for TV shows. I hope you catch my colleague's Todd's talk about operational transform yesterday. I also make Textile with JavaScript. So this is my completely side project talk, not my day job talk. But I'm going to talk about how trying to knit with JavaScript taught me a lot about computer science and making web application better. So it all started with a few years ago. I was living in New York City. I did not have a work authorization yet. I just moved to New York City. And I was waiting for my green card, and I had nothing to do. I couldn't work. I used to be a project manager in Tokyo, so I was like comfortable around being tech, but I was never a coder. So I picked up on teaching myself JavaScript, and I'm a hobby knitter. So it was winter. I was learning JavaScript while I was knitting scarf, and I noticed that knitting is like coding. It's like a very binary process. So the image, it's not showing up. Anyway, so the most atomic unit of knitting is 2 stitches, which is knit stitch or purl stitch. Knit stitch pulls the yarn from the back of the loop, and purl stitch pushes the yarn from there. And then it makes 2 distinct faces of the fabric. This combination of 2, if you may say binary, creates a pattern. Like the 2x2 ribbing is a knit, knit, purl, purl, repeated. The other side of the pattern that's a little more intricate, but if you really closely look at it, it's just a repeat of knit and purl stitch, but shifting to left, one row by row. And also I noticed that the knitting pattern comes like code. So if you download your knitting pattern from online and trying to knit a scarf, the instruction you get is like this. And I was like, this totally looks like code. And I come from Japan, and in Japan, we use graph paper and symbols. So it's a lot more graphical, and I never thought of knitting as a coding. But US style use symbols and instruction to do a pattern. So here K5, K2, like same letter, number, looks like variables. Here's more explicit one of loop, like until 2 stitches remaining, or repeat from. So I was like, this is interesting. I can knit with JavaScript now. So I wrote a little code to interpret this knitting pattern and output an image, much like I was used to knitting and graphically in Japan. And this really got me really interested in I want to try more patterns and then see what comes out of it. The problem is that the knitting scarf takes a lot of time. And if you think about software engineer's salary, making a knitting scarf is an expensive process. So I was like, let's make it really fast. I found this machine called Knitting Machine. And I'm going to, so since it is an Internet of Things track, I'm going to talk about a lot more about hardware. I usually talk about image processing side of this hack. But this is a machine from 80s. They are not making it anymore, so you only have to buy it from Craigslist or eBay. It runs from $100 to $500. I would not pay more than $700 for this kind of machine. But it makes a knitted fabric like a scarf of a person. So this is my co-organizer of a meetup that I ran in Brooklyn. I took a photo of them and then created it into scarf. I have it in here if you want to see it in person. Or if you're into ops person, then you can just get your data as a scarf. So this is very funny. So the Travis CI, the API had an outage. That's the dip there. And somebody randomly tweeted about I really want this graph to be scarf. And somebody who saw my talk in Berlin, Travis is based in Berlin, tweeted at me saying you should talk to Mariko. And I was like, oh, I'm totally gonna make that. And then Travis CI was happening, the all hands was happening, so I sent it to them as a gift. But seems like a lot of people are interested. Or you can just do JavaScript all the way. So I made this scarf. That's the pink version. This is the green version. I used to be a data visualization person. So I was very comfortable with making D3. And I always thought that the the D3 graph to be somewhat like wearable would be cool. So I created a SVG graph of a sorting algorithm visualization that was done by Mike Bostock, creator of D3, ported it into an image, and then knit it as a scarf. So those are the things you can do with knitting machine easily without spending a lot of time. So the inside of the knitting machine, now going into hardware, looks like this. And what it means, that means the green part is a computer from 80s that has chip and bunch of stuff on it that has embedded program to deal with data. It has a serial port that talks to, in 80s, talks to floppy disk drive. The hardware part is a little, it's simple. Now I know I spent 10 months working on this project that it's really simple. It took me 10 months to understand it. However, hardware part is very simple that it has 2 sensors at the end. And you saw the video that I was moving the carriage back and forth. So that those 2 sensors are just seeing if the carriage was knitted the one low or not. And then in the center, they have rotary encoders. Rotary encoders, those who don't know the hardware, is basically a handle that goes like this way and that way. Well, there's 2 rotary encoders so that it keeps track of where that carriage is and which direction that's moving. And then inside of that, the box, there is a solenoid, and I'm going to show you what solenoid is. Solenoid is basically a pin that's moving if it's not having electricity on. And when there's electricity and electromagnetic is happening, then this pin will move. So from here, this white rolling thing is moving a pin underneath of the machine mechanically to transfer the data into that carriage so that there's a, the machine can knit either a base color, in this case white, or the highlight color, in this case green. So, fun fact, if you're doing hardware hacking and your code is perfectly working fine, your solenoid is like just holding the pin that you need, but your output is not working, that means you need to maintain the mechanics part of it, which is like completely out of your code. And you just have to like clean it and then oil it and just have machine in 80s, you have to deal with it. So let's talk about embedded program and how to talk to them. The machine was designed in the 80s. It came with this kind of a Nintendo-like device that is supposed to hook into your TV, and then you program your pattern and then save it into this cartridge here, or you have external floppy disk drive, and you have a serial cable, and then you port it into the device. Somebody back or find out that the protocol that this device and the machine was speaking, and wrote a script to talk to this from your computer. All you need is serial to USB cable, which you can easily get at a company like Adafruit. There's a Python version and there's Ruby version, and I was like, why not Node version? So that's what I did. This is a sketch of me trying to figure out what those Python and Ruby versions were doing in order to make my code work. So the process is somewhat simple. So you have some kind of image that you want to use for your pattern, and you need to make one bitmap image. And if you want to know about how to turn color photo into just a black and white dotted photo, I'm more than happy to talk about that. And you use that image, turn it into binary file of these bunch of hexagon numbers, and use a floppy disk emulator to talk to the knitting machine. In this process, I learned a lot about a data format. I learned about typed array and a lot of buffers. And now I can see that, oh my gosh, computer reads binary. I can finally understand this. I've never thought why. So let's do this. The making a 1-bit image part, I use a browser and Canvas API, since Canvas give you all of the information you need to do this. So those of you who played with Canvas before, once you load the image into the Canvas, you can get data out of the Canvas, and those data are the colors of each pixel. So you have red, green, blue, and you can just manipulate however you like, grayscale it or make it into 1-bit a bitmap file. So I have an array there. And then I create another canvas to load those data in. And then I convert that canvas into data URI so that I can download as an image from browser. So somewhat simple. In the process, I learned a lot about typed array. I didn't know those array that Canvas use are a thing called typed array, which is total lie because it's not array, it's array-like object. So if you learn array.isArray, it turns false. There's like a whole bunch of things that I didn't learn because I guess I didn't go to computer science college, but it was total surprise to me that I've been coding JavaScript for 3 years and never dealt with typed array. But now I understand it, and I can just make a sophisticated choice if I need to be. So now you have 1-bit image. Essentially, it's just the image represented in 1 and 0, black or white. And you turn it into binary file. Binary file is done in Node.js. So it has a whole bunch of algorithm to compress the data, those array of 1s and 0s, into hex value. So one hex value, in this case D and C, can hold 64 bits, like 1s and 0s. So, that was relatively easy, just looking at the flow of how the other programs are compressing the data and then load a bitwise operation script to go in there. Now I have a binary file. How do I put it into the machine? Well, the floppy disk emulator is currently, as it stands, currently run in Python. And I'm sure that we can rewrite it in Node using Node serial port, but I haven't had a time to do so yet. However, because it's Node, you can just use child process to use the Python script inside of your Node script. So in this workflow, I am creating an image on my browser, downloading the image, put it into Node on my command line, and then command line starts the FD emulator and then talks to a knitting machine. However, I wanted to make it a one-stop, so I wrapped it in electron.js so that in one platform I have access to Canvas as well as a FS and buffer and child process where Node API provides. So Electron or NW, I tried it in NW.js first. Those library to make desktop application worked really well for me. So now we know how to talk to those embedded systems. Let's just talk about hardware. The hardware, the embedded machine that I have use a computer and essentially just sending a data, 1s and 0s data. A generation before, the model before that was made in 70s, literally use a punch card that's feeded into the machine, and whether there's a hole or no hole, it transfers data into those solenoids that's holding the pin or not holding the pin. So in that case, I was like, I can make this input, the punch card input, and talk to knitting machine. So that's what I did. So the idea of using punch card to make a textile came from a loom, a different type of textile machine called jacquard loom, which essentially use a punch card to select those thousands of needles to make a pattern. And that became an idea for Hammond-Hollerith tabulating machine, which was used in US Census, which then became computer, which then that company became IBM through acquisition. So it's really, the textile machine is a base of computer, or was a base of computer. I was really interested in it. I created So I created a demo of punch card where you put the punch card, the pin that has a hole won't push, the pin that doesn't have a hole get pushed and makes a contact with the copper at the end, and then that generates a textile pattern and then make a textile knit it. And that's the loop GIF of how this setup is made. So the machine looks like this. It's just a simple folding wooden block, which TSA doesn't seem to be, that's just a block and a pin. They seem to be very interested in that part, not my box full of electronics. They thoroughly investigated just essentially just a giant block of wood and pins. I don't know why. but that's how it's made. And how this is laid out, since it is an Internet of Things talk. So each pins, I use the Jhonny-Five, the JS Robotics framework. In this case, I'm not using it for robots, but it works for any hardware. I'm using each pin as a Jhonny-Five button. And every time the button is pushed or released, I am emitting a socket message. So I am including a socket I/O inside of a Jhonny-Five board. And so when the event happens in Jhonny-Five, I emit a socket event to my socket I/O server with the message for hold or release and the number of the pins. On the server side, I have a very simple express learning where it always has a 8-bit pattern array. And every time that the emit message comes in and then leaves the pin number, change that number inside of the pattern array and then evaluate it however you like. So in my previous demo, I used it literally to turn pixel black or white, but also you can use that into, say, ASCII value and then just encode it into letters. So that project what came out of that project was this GitHub repo I created, IoT boilerplate, which is essentially just a simple system to easily make an Internet of Things with your computer, Arduino, and some kind of hardware. So I already laid out a simple XF server. I already have a, let's see, on the client side, I already have a socket I/O included in the client code. And all you have to do is change, say, LED part, here I have, into buttons or sensors. And whether you want, what kind of message you want to emit. So this became a base of all of the hardware project I do. So I'm going to show you a few examples of Internet of Things project that I did. One is this light. So I organized a meetup called Brooklyn.js in Brooklyn, New York. And we had this event at a theater setting, but we were really low budget. So we wanted to do something special, but we didn't know, like we couldn't really rent anything. So I just went out to buy a $30 LED, put it into the cardboard, hooked it into Arduino, and hooked it into my laptop, running my boilerplate, and created a little interface for users to see from the phone. So while the event is happening and the speakers are speaking, people can go onto the website and then change the color of the LED. And so part of the reason why I did this was that we had a karaoke after party at the venue. And here's a picture of Rick Waldron, the creator of Jhonny-Five, singing and dancing in front of the plop that was made with his framework, which I thought it was kind of cool. And I thought that everything was powered by JavaScript was kind of cool. So in this exercise, I needed to learn how to approach custom sensors because my buttons that I created with the 8-bit punch code computer is not a sensor you can buy from Adafruit. It's not, has a model number. So what it came down was that everything is just a wave of electric current, and all of the sensors are doing something in a different way. And I understood this from doing this exercise of playing with conductive yarn. So I was interested in the conductive yarn and knitting some kind of touch sensor out of yarn so that I can make wearables. And I was talking to Francis Glada, who is also a contributor to Jhonny-Five, saying, so Francis, I created this thing. And this yarn thing usually has like a little bit of electricity. And then when you pull it, it gets more electricity. And I want to just like have a threshold and brighten up the LED. What's that? And he gave me a hint to, it's actually force sensitive register. So I just copied that code and then it works perfectly. So from there, what I learned was that like each sensors are just like interpreting these like numbers and the electricity into a different way. So if you are working with custom sensors or custom hardware that you wanted to make, and that is not available in Jhonny-Five documentation or any other hardware documentation, you can still think of, okay, what does this thing do, and what's the closest sensor that you can buy from Adafruit or SparkFun. So this whole exercise over the 10 months taught me a lot about data, a lot about hardware and electricity. And, I just wanted to knit with JavaScript because I was, bored and like it was cold and I thought it was a fun project. But turns out doing so for 10 months taught me a lot about computer science and how computer actually leads and how computer is actually working. So just find something you like, and I suggest you do the JavaScript all the things. Here are some links to the project that I've been talking about. So thank you.